Today we're going to focus on finding parametric models. And what we mean by a parametric model is that it's a class. It's a model that represents a set of instances where each instance can be represented by a particular setting of the parameter or the parameters. So for example, a line is a parametric model, a circle is a parametric model, and like I said, we'll even be able to talk about a parameterized template, where you have a template, but you change its shape according to the value of some parameters. So when you're trying to fit a parametric model, or another way of saying it is you're trying to find a parametric model inside your image, there are essentially a couple of things you have to keep in mind. The first is, what parametric model are you going to use? That is, how are you going to represent, how do you go from the parameters to the thing you're representing? And in fact, today we're going to show you that even for something as simple as a line, how you do your parameterization matters. The other thing about this model, and this actually works to our advantage, is that the membership, or the notion that a little point in the image or an edge or a template belongs to a model, is not determined by just looking at that edge. You actually have to look at many different edges or look at the whole model. And that notion of extended support is something we're going to take advantage of. And then finally, whenever you go looking for a parametric model, you could just say, well, if computers were infinitely fast, and every time we use one, they feel like they're becoming infinitely fast, well, I would just check for every possible line in all possible places. Well, the reality is that even with really fast computers, the number of possible models is really big. So it turns out you're I'm losing track here. It turns out you're a really fast computer. Still, you have to worry about the combinatorics of your computation.